those of you that started it on your own, we'll see if you're going in the right direction. So this question is asking how much 8% and how much 23% solution should be mixed to create 240 milligrams of a 14% solution. So as we did last week, we're looking at what we are mixing, and here we are mixing 8% and 23% solutions. And what we are trying to create, or what we want a 14% solution. Then we need to look at the things that are conserved or preserved. The total volume, total mass is something that stays constant. So looking here, we have 240 milligrams of the 14% is what we're going to create. This is going to be an equation here. It's going to be equal sign. I have to pick one of the other two amounts to be x, and the other one will be the total, 240 minus x. And if I add those together, we'll see that those do add up to the 240 milligram total. Our next step then is to write the equation that shows the amount of active ingredient, in this case the amount of medication that is in there. That is another value, another total that is conserved. And remember, the amount of that solute, or that active ingredient, is the concentration. So for our first solution, that's 8%, so that'd be 0.08 times the volume. So the volume there is 240 x. For our second solution, it's 23%, so that concentration is 0.23. So we're going to add that to the first one, times its volume of x. And of course, that will add up to the amount of active ingredient in our final product, which is 14%, so a concentration of 0.14 times 240 milligrams, that amount. Now it'll be a matter of just solving this equation to find x. So we have 0.08 times 240. What does that give us? 19.2, I believe. Check it. It is 19.2. 0.08 times negative x is a negative 0.08x. Then we here 0.23 times x is just 0.23x. Now there's still more I can combine here, so let's do that first before we move on. I have negative 0.08x and a positive 0.23x. Negative 0.08, positive 0.23 gives me a positive 0.15x. I still have that positive 19.2. On the other side, on the right side, I just have to combine those 0.14 times 40. Now I have an equation that we're ready to solve. So let's go ahead and subtract the 19.2. 0.15x equals 14.4. And I'll divide by the 0.15. X equals 96. Now, as always, we need to make sure we know what that x represents, and then we need to go back and make sure we've answered our question. X was 96. That represented the amount in milligrams of the 23% solution. We do still have to get the amount of the 8% solution. So that's 240 minus x, or 240 minus 96, which would be 144 milligrams of the 8% solution. So we've answered that. Now, I realize many of you have probably had, at this point in your high school career, Algebra 2 or Advanced Algebra. A problem like this actually could have been solved with a system of equations. We avoided the system of equations by doing this 240 minus x, but we could have very well done a system of x plus y equals 240, and then 0.08x plus 0.3 y equals 0.14 times 240. And then we would have just had to solve a system of equations. We're not going to require that in here, but some of you may have solved mixture problems like this with that system of equations. To me, this is actually easier. It results in the exact same equation, by the way, because you just use this to substitute in down in one of these two variables for x or y. Okay, so enough of those. Let's talk about some of our other uses for variables. We'll come back at the end of class today. We'll fill our time with more examples of difficult equations or complex equations to solve. But I want to take a look at other applications. One of them we said was formulas. And our formulas can be used for a lot of different things. We said that the values in those formulas can take on any value within a naturally restricted range. So you might have a formula, a mathematical formula, in the perimeter of a rectangle. Find the perimeter of a rectangle. It's 2 times the length plus 2 times the width. So if we are given, we might ask to evaluate for L equals 16 inches and W 9 inches. So that's asking us to do is replace the variables in this formula with those values that each variable has been assigned. So P equals, instead of 2L, it's 2 times 16. Remember, the number in front of the letter means it's multiplied by that number. Plus 2W is going to become 2 times 9. And now this right side of this formula has just become an order of operations problem. Multiply first. Times 16 is 32. Of course, we have to move left to right. Next multiplication is the 2 times 9. 18. And finally, we have the addition. 32 plus 18 is 50. Our perimeter is 50. And of course, the units there were inches. Now, as we get into more advanced, some of our medical formulas, we're going to keep the units in the formula as we work, just so that having the units in the formula and making sure the units work out is one way of double checking to make sure that we first use the correct formula and that we have done the calculations correctly. Another formula that's pretty common that we're actually going to use a lot is converting pounds, kilograms, or the other way around, kilograms to pounds. If I'm going pounds to kilograms, A is equal to P over 2.2. So I might ask you to evaluate that for P equals pounds. Put in our P, 88 over 2.2. This is going to simply be divide 88 divided by 2.2. Patient that comes in as 88 pounds is 40 kilograms. Another common formula we work with is converting degrees Fahrenheit to degrees Celsius. We are used to, on an everyday basis, using our standard measurement, which is something we'll actually go through later on in this unit 2 here. Inches, feet for length, pounds, ounces for weight, degrees Fahrenheit for temperature. Well, in the medical field, because so many things are international now, things have been switched over a lot. Much of it is done in metric units. So kilograms for, technically it's not weight, we use kilograms, it's technically mass. Centimeters and millimeters and stuff for length, and degrees Celsius for our temperatures. So the formula to convert degrees Fahrenheit to degrees Celsius is our Celsius temperature is equal to 5/9 times Fahrenheit temperature minus 32. So one temperature I like to convert here is human body temperature. Is 98.6 degrees Fahrenheit. So if I'm converting that into degrees Celsius, I replace the F here with the 98.6. That is the Fahrenheit temperature. Equals 5/9 times. F is replaced with 98.6 minus 32. Now, once again, it's order of operations. We have parentheses, so we'll do the 98.6 minus the 32, 66.6. Now, we've reduced the parentheses to a single number, so I can take it out. Remember that parentheses represented multiplication, so it is 5/9 times 66.6. And if we multiply that out, we get 37 degrees Celsius. Now on your calculator, if you don't have a fraction calculator, just do 5 divided by 9, then times 66.6. Got 37. Now there are oftentimes, here we were just doing a single conversion. Let's say we want to convert 20 degrees Celsius to Fahrenheit. I can still use that same formula if we have to. E equals 5/9 times, and in parentheses, the F minus 32. 20 degrees Celsius, though, goes in for C. And now this becomes an equation that we are going to solve, just like we did last week. Now what we did last week when we ran into something like this was we distributed the 5/9 through the parentheses. But since there's nothing else on the right side of the equation with that, everything on the right side here is being multiplied by the 5/9. Because all there is that parentheses and the 5/9. So since the whole right side is being multiplied by the 5/9, rather than distributing it, we could just divide by 5/9. Cancel it out. Now 20 divided by 5/9, 36. On the right side, the 5/9 has disappeared. We just have the F minus 32. I don't need the parentheses anymore because the multiplication is gone. Those of you that are wondering, how does 20 divided by 5/9 give us 36? Well, remember that's 20 over 1. And we convert it. The 20 over 1 doesn't change, but we convert this to times 9 over 5. Now I can cross cancel here to reduce. 20 and 5 both divide by 5, giving me 1 and 4. And of course, 4 times 9 is 36. 1 times 1 is 1, giving us the 36. Now, of course, there's one final step to solving this. We have to add the 32. 8 degrees Fahrenheit temperature. So 68 degrees Fahrenheit is equivalent to the 20 degrees Celsius. So now here we were using this formula backwards. We were given the result, that this number over here, and we were asked to find a value within the formula. We were able to do that fine because we know how to solve an equation. But it's definitely more work to go that direction than it was up here where we're given the value in the formula and just did order of operations to kind of combine the numbers, get that singled out value. If we were only doing this once, I'd probably do it exactly the way I just did. Put in the number, solve the equation, find the other number. But if it was a calculation we had to do over and over again, let's say that every time we took a patient's temperature, the thermometer is going to give it in degrees Celsius, and we needed to convert it to degrees Fahrenheit. It's something I had to do a lot and do it over and over again. I would want that formula to be rearranged so that it was just plug in the number and do the order of operations. So I have that formula, C equals 5/9 F minus 32. What we can do is we can rearrange a formula. It's called solving a literal equation. We'll rearrange the formula to solve F. Here we're solving for this F, which means we have to get rid of everything else. If I look at this to see what has been done, F, this equation. Order of operations says the parentheses happened first, so 32 was subtracted from F, and then outside the parentheses, the whole thing was multiplied by 5/9. Well, just like we solved equations before, we can do the same thing here to take this apart. We're going to start by getting rid of that last piece first, which was the multiplying by 5/9. The opposite of multiplying by 5/9 was dividing by 5/9. C divided by 5/9 is the same as C times 9/5. Remember, we multiply by the reciprocal when we divide by a fraction. This becomes 9/5 C. On the right side, the 5/9 is canceled out, and all that is left is the F minus 32. We don't need the parentheses anymore because the multiplication is gone, so I'm going to drop those out. Now the last thing we need to do here to solve for F is to get rid of the minus 32. Get rid of that, we're going to add 32. Now on the left side, 9/5 C plus 32. We can only add things that have the same name. Well, because the 9/5 has a name of C and the 32 has a name of ones, we can't combine those any further. That just simply becomes 9/5 C plus 32. On the right side, the 32's cancel out, and that is just F. So now we have a formula that is solved for F. I can rearrange it by putting the F on the left side, just saying F equals 9/5 times the degrees Celsius plus 32. So if this is a calculation I have to do over and over again, that formula has been rearranged to make it easier. I just plug in the numbers and do the order of operations. We may have a formula like, well, let's go back to perimeter. Perimeter equals 2L plus 2W. And let's say we're in a situation where we're going to know we will be given perimeter and the length repeatedly, and we're going to be asked to find W. So what that means is I want to take this equation here and I want to solve it for W. I'm going to have to do that repeatedly. Oh, I have P 2L plus 2W. So we need to focus on the W, and of course just on the side of the equation that has the W, and we need to figure out what is keeping the W from being alone and how it was attached. In other words, we need to talk about what was done to W if we were just focusing on W. Well, the first thing that would be done to W is what is multiplied by the 2. 2 is right there. The next thing that would be done if we're focusing from the W is the 2L was added to it. That's it. That's everything that's on the right side of the equation, keeping W from being by itself. So if we had to solve this, we would have to reverse that process. To get rid of adding 2L, we have to subtract 2L. Subtract 2L here, we'll cancel that 2L out. P minus 2L is going to be simply P. Now we need to get W by itself by getting rid of the 2. The 2 is multiplying W, so we're going to divide by 2. Now we subtracted up here. Remember when we subtract, because when we add or subtract, we have to have the same name. We only combine it with things that have the same name. That's why P minus 2L became just P minus 2L, because they didn't have the same name. But remember, when we multiply or divide, we don't need the same name. So we can combine it with anything. And when we multiply or divide, we have to work with every digit, every item. So we divide by 2 on the right here. That gets rid of the 2. On the left, we divide by 2. We have to divide this whole side by 2. Which means, technically what we're doing is we're doing the P divided by 2 and the negative 2L divided by 2. That'll give us the W on the right side. So we're dividing each of them. P divided by 2 is just going to be P over 2, or 1/2 times P. I'm just going to keep it as P over 2. Minus 2L over 2. Well, the 2's cancel out. Just minus L equals W. So we have simplified that formula. One thing that we're going to look at in Unit 4 briefly is taking equations like this and we're going to solve for y. The same process, same concept. Get y by itself here. We have to look at what has been done to y. Y has been multiplied by a negative 5. This is a negative 5 multiplying y here. And the 4x has been added to it. So when we go to take that apart, we'll subtract the 4x. Now again, when we add or subtract, we can only do it to things with the same name. So we only do one piece on the left. We subtract the 4x and it's gone. We have the negative 5y left. On the right, there's nothing with the name of x. So 10 minus 4x is just going to be 10 minus 4x. Then we have to divide by the negative 5. Dividing by negative 5 on the left side, we only have the negative 5y. It's only a single digit. So we'll divide out the negative 5. On the right side, we have to make sure we divide each of those pieces. So on the left, we have y. On the right, each piece, well, 10 divided by negative 5 would be negative 2. Negative 4/5 divided by negative 5. Well, first of all, this is a negative divided by negative, which means it's going to be positive. Second, remember we said division and fractions can be kind of interchangeable. Flip back and forth between them rather quickly. 4 divided by 5 can just be turned into the fraction 4/5. We have the x. So y equals negative 2 plus 4/5 x. Another formula we have that's very common, popular in medicine, is body mass index, BMI. BMI, one of the estimators, so there are several estimators. The more complex they are, the more accurate they are. But one of our simple but still sort of accurate estimators of body mass index is the formula BMI equals W, which is your weight, over your height squared times 703. So let's first evaluate this. For a person with a weight of 300 pounds and a height of 6'2". I'm going to take a risk and put my own numbers in there just to see. I haven't checked them for a while. Let's see how bad it is. So 300 pounds, that's just fine. That's going to go in for W. H is 6'2". H has to be in inches for this formula. So 6 times 12 is 72 plus 2 is 74 inches. That's what we're going to put in for H. So BMI, the W is 300 over 74. H squared is going to be 74 squared times 703. Now it is just order of operations. We would do the 74 squared first. It's going to give us 5,476. Then we'll do the division. 300 divided by the 5,476. Gives us this ugly decimal. I'm going to write down some of it, 0.0548 times 703. Now notice I did not hit clear on my calculator. I'm just going to leave that number in my calculator. Because if I write it down and type it in, it's going to have some sort of round off error. So I'm just going to leave it there and do times 703, which is going to give me 38.51. So somebody with those measurements would have a body mass index of 38.51. So if we look at that formula, BMI equals W over H squared times 703. And let's say we want to find W if H equals 5'10", and we want the BMI 20. So we could plug in that 20 for BMI. W over 5'10", well, 5 times 12 is 60, plus 10 is 70. H is going to be 70, so it'll be 70 squared times 703. Now we do have to solve for W. I'm going to start by combining the 70 squared, which is going to be 4,900. Now I do my 20 divided by the 703. So 20 divided by 703 is going to give us an ugly decimal as well. I'll make sure I keep that in my calculator. The 0.02845. That there. That equals on the other side over here, the 703 is canceled out. We still have W over 4,900. And you'll see again, we just need to multiply by the 4,900. On the left side, I'm just going to leave that number in my calculator, make sure I don't hit clear. I'm just going to multiply by 4,900. So 139.40. What that is telling us is if we have a person who's 5'10" and they want their body mass index to be 20 or less, they have to have a weight of 139.4 pounds or less. Just like we saw before, we could rearrange that formula. BMI equals W over H squared times 703. By solving it for W. Now here, there's no number in for H, so we don't start by squaring it. We're just going to start solving. So we're going to divide by the 703. Well, when we divide by 703, on the left side, BMI divided by 703 is just going to become the fraction BMI over 703. W over H. And now to get W by itself, we'll multiply by H squared. That out. BMI over 703 times H squared. mi over 703 squared. So we have rearranged that formula to make it simpler to find the weight of a person, or the desired weight of a person, with a given height and a desired BMI. Last week we looked at solving equations, and we just started some more difficult equations, and we ran out of time that day. So I want to take time to do a couple of examples here. One is something like this. X over 7 plus x over 4. So in an equation like this, of course, the variable appears twice. But the key to solving this equation is to understand what x over 7 is. Now that is, x divided by 7 is one way to interpret that. But another way to interpret it is 1/7 times x. Think about it, 1/7 times x, that's 1/7 times x over 1. X times 1 is x, 7 times 1 is 7, you get x over 7. But thinking of it as 1/7 times x makes it easier to work with this problem. So 1/7 x plus 1/4 x equals 33. Now this is very similar to having like 3x plus 5x equals 48. We could add the 3x and 5x to get 8x. 48. Over here we do the same thing. We can add the 1/7 x and the 1/4 x. Well, 1/7 plus 1/4 is 11/28. I'll let you guys do the math on your own to confirm that that adds up. So 11/28 x is our 1/7 x plus 1/4 x. Equals 33. And now we will solve. Getting x by itself, x is multiplied by the 11/28. We will divide by 11/28. X equals 33 divided by 11/28 is 80. X equals 84. Now, just like in all of our other examples last week, if you wanted to, you could double check this. You could go back to that equation, x over 7 plus x over 4, 3. And you could plug 84 in for x. 84 over 7 plus 84 over 4, 3. 84 over 7 is 12. 84 over 4 is 21. And of course, 12 plus 21 does equal 33. So we have the same value on each side of that equation. A little bit more interesting equation. Actually, a more common way of solving an equation, like x over 7 plus x over 4. A lot of us don't like to work with the fractions. So what we were taught to do is find that least common denominator. Our least common denominator here between 7 and 4 is going to be 28. And what we did with that least common denominator, either we multiplied the whole thing by the least common denominator, or we just converted everything to that denominator. Turn a 7 into a 28, we had to multiply by 4. 4, that gives us 4x over 28. Turn the 4 into a 28, we multiply by 7. So x times 7 makes that 7x over 28. Equals, on the other side, we would want to do the same thing. 33 over 1 becomes 924/28. And there we have an equation where we have common denominators on every term of that equation. So what we can do is simply multiply the whole equation, both sides, by 28, and it cancels out the 28s. So that now becomes the equation 4x plus 7x equals 924. And from there, 4x and 7x add up to 11x equals 924. And we can divide by 11. 924 divided by 11 is 84. X equals 84. We get the same answer. In this example here, the x over 7 plus x over 4 equals 33. If you're good at working with the fractions, or at least okay at working with the fractions, that was probably the simplest way to do it and probably the least amount of work to solve this problem. But we do need to be able to find this least common denominator and use it to eliminate the fractions in the equation. Because we do run into equations where the variable is in the denominator. We did one example last week. We'll do another example here. 4 plus 6 over x plus 2 over 5 equals 3x. So here we have denominators 4, 5, or sorry, not 4, x, 5, and 2x. Those are our denominators. Now, first thing we do is we ignore the variables and we just look at the numbers. Our least common denominator for 2 and 5 is going to be 10. For the variable, then we just look at the highest power of the variable. Well, this is just an x here, so it's just going to be 10x is going to be our least common denominator. So for every item in this equation, I need to make the denominator a 10x. Well, this is a 4 over 1. To turn the 1 into a 10x, I have to multiply by the full 10x. So 4 times 10x is 40x over the 10x. This one already has an x. To turn that into a 10x, I'm just going to multiply by 10. So I multiply by 10 on top. 6 times 10 is 60 over 10x. Plus, here to turn the 5 into a 10x, I have to multiply by 2 to make it 10, and x to get the x. So I'll multiply by 2x on top. 2 times 2x is 4x, and of course that's over an x. Equals, on the other side over here, to turn the 2x into a 10x, I just have to multiply by 5. So I'll multiply the 3 by 5 as well to get 15 for 10x. Now again, everything here is over the same denominator, over 10x. So if I multiply by 10x, or 10x over 1 if you want, it cancels out each of those 10x's, giving me the equation 40x plus 60 plus 4x, 45. And now we can go ahead and start combining what we can on either side. 40x and 4x is 44x plus 60, 45. We're ready to solve, so we'll subtract 60. 44x is a negative 50. And we'll divide by 44. X equals negative 15 divided by 44 is just that, negative 15 44ths. Again, we can, division and fractions, we can flop back and forth from one to the other. And we can just make that a fraction and try to reduce it. Here it doesn't reduce. So that is our final answer. X equals negative 15. Okay, with our last few minutes here, I want to make one mention before I give you the homework. Unit 1 test. All of them have been turned in, graded, and I have returned them to your schools. So hopefully you have them back. If you haven't got it back yet, make sure you talk to your contact person. You are allowed to do corrections on the test. Do corrections on the test. You redo any problems that were incorrect. Now, the thing when you redo them is you must show your work. Show every step. If you can figure out what you did wrong the first time, make a little note of it. Redo those, showing all of your work. Then resubmit it to me. Have your person there scan it and send it to me, or you can scan it and send it to me yourself. You all have my email address. And that would give you back up to half your points. So let's say you had a score of 84%, or 84 points out of 100. If you do those corrections, that turns that into a 92. So it makes a big difference on your score. Even if you have a 97 or 98, getting back those few points can make a big difference at the end of the semester. So please make sure you do that. If you have any questions on those, feel free to ask me. I will work through any of those questions with you that you need me to. Or you can work with your classmates or other teachers at your school if you like. Anybody have any questions? Okay, so your homework, give me a couple of pages here, page 60 through 61, 1 through 47 the odds, and then 61 through 65 the odds. This is going to be using formulas. And then page 67 through 68, 1 through 27 the odds. This will be rearranging those formulas. That is it for today. So we will hopefully see you all on Wednesday. Have a great day.